So, this is about beyond consumer-driven contract testing, and what this actually means is what I'd like to tell you in the next hour or so. All right, so let's suppose we want to build this nice web application, or we have these microservices, or the self-contained system, or a distributed system, whatever. And we want to ensure that the front end and the back end play nicely together, of course, right? And we don't only want to discover in production that they actually, don't understand each other, right? Who of you is in this situation that you have front ends and back ends that need to talk to each other? Okay, so probably almost everybody. That's good. So you're in the right talk. The question, of course, is how can we make sure that they play nicely together, right? And there are some approaches out there in the wild, and I've tried to sketch them a little bit so that we, get closer to my ideas, like closer and closer. And so the first thing that I've observed out in the wild is something I'd like to call the super naive approach. And it goes like this. So you have a front end and a back end. From now on, I will always refer to front end and back end. This also applies to different services talking to each other. It's just an example. So I think this is very a good picture. You can remember what I'm referring to, but this also applies to all sorts of things talking to each other via APIs. Okay, so we have this front end and the back end, and then the back end says, okay, we'll define an API. And then the back end gets implemented. So here I visualize the back end via Java and JUnit tests. Of course, this also applies to all sorts of backends, right? So the backend develops against the API, and once the backend is finished developing, then the front end comes and is also being developed. And this is also here symbolized by JavaScript, but this also, of course, applies to all sorts of stuff. So, and after we have established first the backend and then the front end, and then have them talk to each other, we can do some integration tests, like Selenium, for example. And so we can make sure that they actually work together nicely, right? Is anybody using something like this? Wow, quite a lot. Okay, cool. So, but the question is this a good idea? And I think there are some drawbacks to this. Because first of all, the front end is blocked until the back end is actually done, because the front end doesn't have anything to talk to, so you cannot, it's not really blocked, but finishing it is blocked, right? Because you need to be able to do the integration tests with a fully running backend and fully running front end. So there are some, serial aspects in here, so you cannot do this fully in parallel. The other thing is, probably all of you know, Selenium is not the fastest, or visual integration testing in general is not the fastest, and also it doesn't really scale well. So once you hit the point where your nightly tests take more than 24 hours, then it doesn't scale anymore. Okay, so we can do better. There's another approach, and I'd like to call this the still quite naive approach. And it goes like this. We have a front end and a back end again, and we have this API again. And what we do now is, first of all, we establish a mock for the front end so that the front end is decoupled from whatever the back end does, right? So we can now develop the front end and the back end in parallel. The back end provides the API in the end, and the front end can always be run against this mock so we can see how it behaves and everything, okay? And then we can have integration tests, but this time we can only run them here on this side between the front end and the mock. So they are a bit faster, and we don't have this nasty setup, in Jenkins or so, where you have to make sure your backend server is up and running, and then the front end is up and running, and everything's talking to each other, and then it breaks, and your tests break, and you have no idea, and this is a bit nasty. So is anybody using like this? Okay, a few, okay, like sort of. Yeah, I mean, this is like, dynamic. Okay, cool thing. But, of course, also here I see some drawbacks. The biggest thing is you have this API and you have this mock. They're totally unrelated, right? So what if the backend decides, oh, this API actually doesn't really work and we cannot provide this data in exactly this shape. We need to modify it a little bit. And so the API moves in shape and size. But the front end, the mock, doesn't know because, it's just separate. And so they diverge and you put them in production and think, yay, everything is cool, and explosion. So, yeah. And then there is another approach which I would currently call the industry strength approach, and that's consumer-driven contract testing. Has anybody heard of this already? Oh, quite a few, cool. Does anybody use this in production? No? So in production, nobody uses this. But you tried it out a little bit. Okay, nice. So consumer-driven contract testing, you probably all know, but I will just quickly go over it. Works like this. You have the front end and the back end, and they establish a contract. That's why it's called contract testing. So the contract means they agree on, how the backend should behave. What messages can be sent to the backend, what responses you get back. And then there are tools available on the market, and you can generate a mock for the front end out of the specification and can use this mock in development like you used the previous mock. You can also generate tests for the backend out of the specification, and then in development run the test against the backend to ensure that the backend still adheres to the contract. And so whenever one of the parties wants to move, something will break. So either the front end cannot work with the mock anymore, or the backend tests fail. And then what they need to do is they need to go to the contract and modify the contract. So in here. And then whichever side they come from, this will automatically be reflected to the other side, so that both sides always stay in sync. Okay? And then you have this nice separation, and you can do on each side whatever you want, but you still have this connection through the contract. Okay? So this sounds like a really cool idea. And I will give you, but I also have some complaints about this, and I will now give you a short little application so we can have a bit of a better view what is actually wrong here. So this is a pet store. So this is like the pet management system for the pet store. And what happens here is you can add a new pet. Once a new pet gets into the store, you can add it to like your record of the pets. Here you can specify the name, the price, and the species. And here there's the list of the pets in the store, and then they can be sold and get removed from the list. Okay? And so here we have a GET request. We want to see the pets. Then here we have a POST request. We want to add a pet to the store. And then we have delete requests for each of those pets. Okay? Makes sense so far? Good. So this is an example contract. It's written in Pact, which is one of the tools that's available. But this is something that's rather similar for all of the tools. So this is not something, I'm not picking specifically on Pact, and all the other tools are nice and good, but this is a conceptual thing as I perceive it. So this is a contract. Here we have a description, and it says this is a request for all pets because it's a GET request on our pets URL. And I can specify here a state, which is a string. And then I can work with a string later on. So here I say, okay, I have no pets. And then I can specify the request should look like this. So I say get on the pets URL. And the response should be like this. I get a 200. and I get a JSON object, and here it says, okay, in my body I get a JSON object, it says these are the pets with a list, and the list is empty, okay, because I initially said my state is I don't have any pets in the store, okay? Makes sense so far? And this is all nice and shiny, and you can run these tests and everything works perfectly fine. So the situation here is we have a GET request, which does not depend on the state, or the state is empty, so there's no specific state in our backend system. And this is really easy to handle with CDCT. And whenever I do such a thing, a testing or something, I ask myself questions whether I've covered everything and I've thought of everything, you know. And so here I would ask myself the question of completeness. Did we actually capture all the requests that are there? So for this one, yes, I captured all the possibilities because, you know, I just can send this every time and I get back the empty list every time. There are no varieties in there. And the other question is also, did we capture all responses? And yes. So, but if we move further, because this was a bit of a boring test, and I think we have more interesting cases to cover in our testing. If we look at the next possible test, here I have a description, also a request for all pets, and I go for the same URL again. But here in my provider state, I say I have a list of pets, right? So I just say, okay, let there be some pets in my store. And now in the response, I specify, okay, in the body, I have a list of pets, and they have these and these data. Where does this data come from? I cannot see this here, right? I only say, yeah, there should be some pets. And then all of a sudden, my response must be very specific because this is what gets compared by these tools. And that somehow doesn't really fit together, you know? And so the situation here is that we have a GET request that now actually depends on the state. The same holds true, of course, for the post and put and delete requests, because there it's even less specific, you know. You send a post request, and what's the answer? 200 okay. Yeah, so okay what? I handled the data correctly, or today's Monday, I dropped the data. Okay, you know, you can't tell just by looking at the response. So there needs to be another way of getting into this and making sure that the API actually works correctly. And I think this is difficult to handle with CDCT for the time being, like for this way of specifying stuff, because we need to somehow establish the backend state, and also we need to check this backend state somehow, and we need to make sure that actually the correct thing happens in there. Okay, because that's what I would like to know if I were to write such a system. And again, I can ask myself questions. For example, for the completeness, again, did we actually cover all the combinations? Yeah, here we have lots of varieties. All of a sudden, we can have like just one pet or many pets and same pets, different pets, I don't know. Yeah, like the different combinations. And also, what about the validity of the state? Because to run those tests, I have to set up the backend somehow, because otherwise I don't get the correct answers, right? And so, you know, like in PAC, they say, yeah, you can access the database, and then you can pre-fill the database. Okay, so I pre-fill the database, but do I have any idea whether this is a valid state in my database? I just fill in some data. Is this really what I can expect in production? I have no idea, you know. For example, if I have a business rule that would say I can only sell and buy pets in pairs, then I would always have an even number of pets in my database. But if I just set up the state, like how I think it's okay, I might end up with an uneven, with an odd number of pets in the database. So for this, you can imagine, yeah, that might probably not be the end of the world if I have one extra pet in there. But, I mean, there are cases where you have really complicated and difficult data, and when you set this up incorrectly and it's invalid, then, you know, what do your tests tell you? Nothing, I think, right? And so we need to ask, what are the valid states? And did we always establish a valid state when you set up our database or our server state in general? It need not only be a database, but just to give you an example. And also, how do we technically establish this? So in Pact, for example, you get a pre-setup phase, and there you get the string. It gets passed in, and then you can do a comparison, like if you get this string, then you can set up this data, and if you get that string, then you can set up some other data. But this is all sort of, I don't know, very fragile, very disconnected from the actual specification, contract. And also the question remains, how do we validate the backend state actually after a modifying request was issued, a post request or a delete request? We need to check what happened in there, right? And if you imagine you have a big system or a bunch of systems that use the same database schema, and you have gigabytes of data in your schema, you don't want to compare all of this all of the time, right? It doesn't make sense at all. Also, there are questions about maintenance of those consumer-driven contract tests. How do we keep track of our contracts? How do we make sure that we covered something? And how do we make sure that we don't start to cover it twice or 3 times because we just forget we did the test? This is, of course, the same questions we need to ask ourselves when writing unit tests or whatever. This is just standard what we need to do during our work, but still, we have to solve this problem somehow. And I talk to people and they say, yeah, they have hundreds of CDCT tests, and they run into these issues. They need to figure out, did I cover something? And then you end up having heuristics for organizing your data or naming schemas or something, and this all gets very hand-wavy. So, and also, if you introduce a change, and you would need to touch like a bunch of those contracts because something fundamental changed, like the data changed or something, How do you handle this if you have hundreds of tests? How can you effectively manage those data changes? And these are problems that I don't see are being addressed properly with CDCT. Okay? So, and of course, I don't just stand here and complain, I also have a solution. And my solution is we need the functional essence. So I think boring names are boring, and so I came up with a nice name. I hope I like it. So I hope you like it too. And this is the functional essence, for example, maybe. Okay, so this sounds really cool, right? I think it sounds cool. But what do I mean with this? Okay, so what's a functional essence? A functional essence could also be called a fake server or a lightweight implementation or a model. I mean, we are here at a DDD conference, so I can, say model without issues. But in general, I try to avoid this because this term is so full of meanings in all sorts of contexts. And so if you say model, you immediately send people off on a thought process. And maybe this is totally not what I meant. So, you can think of it as a model, but maybe just think of it as a functional essence. Or you could also call it a rapid prototype, or maybe also a minimal viable product. Okay, so I think now I have covered all of the buzzwords, and now you are so confused that you don't know anything anyway. So, very good. Okay, so what is this functional essence good for? And also, again, I think here at a DDD conference, I don't need to touch on this too thoroughly, but we can actually use this because it's a rapid prototype, right? We can learn about the domain with this, and we can implement it very, very quickly, as opposed to the real backend where we might need to put much effort in it. We can also discuss with the domain experts with this. We could just prototype something, access the API via command line and say, here, look, that's what comes out. Or we make a very simple front-end prototype and just play around with it and let people explore what they want to be implemented. Also, we can validate our assumptions. Does this really work that way we imagine? Does this really fit into the rest of the system or whatever? And also, and that's why I'm talking about this here, is we can actually use this to check the real implementation. And that's what I'm going to show you now, how this would work. So this is the picture of the CDCT we had back a couple of minutes ago. And here we have this contract, right? So what if we replace this contract by our functional essence? And now what would happen, because from the functional essence I don't want to generate stuff, but what I can do is I can immediately use this in development from the front end, because it's a lightweight implementation of my backend domain logic, right? So I can immediately access it. For the backend, I can run a comparison. So I can implement a comparator that would look at the functional essence and my real implementation in parallel and figure out if there are differences or not. Okay? So maybe you think, wow, this sounds cool, but how? Yeah, can I work with this? How can I build this? So, if you want to build a functional essence, the point is you implement the domain logic in the simplest possible way, and you can use an arbitrary language if you want. So now is the time, if you always wanted to play around with this cool new language, but you never got management buy-in to really run this in production, here's your slot where you can actually try this out to get the functional essence. But this is, of course, not the main aspect. Yeah, we want to play around with a new language. No, not really. It's just a nice side effect, And yeah, so for this, then we can use this here in production if we have implemented this. And how do we implement this? Here's an implementation I wrote in Node.js. I initially developed this together with a friend, and he, of course, went for Haskell because that's his language. And so first I thought, okay, I will present this in Haskell, but then the effect is that everybody says, yeah, in Haskell this is all easy, but we don't have Haskell developers, so we can forget about this. Okay, and I wanted to prevent this from happening. So I used the dumbest, stupidest language that I could come up with. Sorry, I don't know any stupider language than JavaScript, Node.js. And so there you go. You have to bear this JavaScript stuff. Okay? So, but you can see you can also even do it in Node.js. Okay? So there is no magical mystery Haskell super cool feature in there. Okay? So, first of all, we define our pets list. So this is the essence for the pets. And we say, okay, initially we have an empty list of pets. Then here we have for the get request, we have something. We return the pets. For the add request, we just add the pet we get. And for the remove request, we remove it from this list. Okay? So no rocket science, just standard, straightforward implementation. Okay? If there are any questions, then just shout. Yeah? Okay. So, of course, maybe we have different aspects to our model, and we don't want to mash them all together, so we can have different models here, like for the pets, and maybe if we have something else we want to sell, then we do a new functional essence for this other stuff. Maybe we sell pet food or whatever stuff you may want to buy for your pet. Okay? So, and then we put this into an application. This is very easy Express code. So here we have the routes, the get request, the post request, and the delete request. And here, basically, we immediately go to our pets essence and invoke the proper message and return this. Okay, so very simple. What we also need, because we need to be able to reset this thing, we need a reset API. Okay, because we want to run this and then we want to say, okay, let's start from scratch. We need this reset to be able to do so. Also, we need this for the real backend. But please make sure, don't let this go into production, okay? So now, maybe you think already, well, okay, fine, so I implement the domain logic, and but actually I do have my real backend that also implements the domain logic, so isn't that like the same or something? Maybe it is the same, but usually it isn't. Because, as I said, you could use another language if you wanted. You can use simpler data types. You know, in production you might have performance issues or performance considerations, and you want to have this high performant, whatever, super complicated data structure, right? But in this functional essence, you don't need this because you don't work with high volumes of data, and you're not, you know, if your tests run 2 seconds or 5 seconds, I mean, do you care? I don't really know. I mean, you know, if it goes to 5 minutes, that's a different story. But here we can keep things very, very simple. We can use the simplest, standardist, out-of-the-box data structures we can find in our programming language. Also, we can use the standard algorithm, you know. We don't need this high-performance sorting algorithm that already had 15 bugs while we developed it. We can just use the standard sort from the language or some library that's available. We don't have any technical overhead, like there was no database, right? I just had this list in memory, so if this functional essence restarts, everything's gone, but I mean, who cares, right? Not for this purpose. I'm not interested in keeping the data, persisting the data. I just need to capture it while it's running. So I can get rid of all of this technical overhead. Also, I can leave out parts because I'm talking about testing through this API. And so only those parts of the system that I can reach through this API are actually interesting for the functional essence. And everything else that I cannot reach, I can safely leave out. So there's no big deal with this. And there are probably some other aspects that I haven't covered here that are also different. And so, yeah, probably it is not the same as your real production backend, I believe. Okay? So now back to our overview picture. So here we have the functional essence, and now we've had a look at how to implement this. The other new thing is this comparator, where we want to compare the functional essence and the backend. And how does this actually work? So if we have this functional essence and the actual backend and our comparator, what should it do? Initially, it would make the same change on both sides, and then it would ask the same question on both sides, and then ideally it should get back the same answer, right? So that's our hypothesis. If we ask the same question and we make the same change, then we get the same answer. And we want to establish whether this holds true. And in order to establish this, we need to take a little detour. So here now actually comes a little bit of Haskell magic, but it's not that bad, and we can easily recreate this. Okay? So, and the Haskell magic is called quick check. Or nowadays people talk about property-based testing. Have you ever heard of this? Oh, wow, cool. Have you ever used this? Wow, same people heard of it and used it. Excellent. So there must be something to it. Cool. All right, so how does this work for the others? The user specifies some properties of the code. And then the system generates examples for this property or for the thing we want to test. And then it checks whether the properties are valid for the examples. So for example, this is actually a bit of Haskell code. Please bear with me. I hope we get through this safely. So here we have a property, and this is called rev, so reverse. And it says, okay, I'll take an integer list and I return a Boolean. So Boolean says, yeah, it holds true or not. All properties return Boolean. And here the property takes a list of x's, and then it calls reverse on the list, and then reverse again. and then the property claims that it's the same as the original list. Do you believe this holds true? This is not a trick question, by the way. Do you think this is valid? If you reverse a list and reverse it again, then it's like before? Okay.
Correct.
Cool thing.
If it's implemented correctly.
If it's implemented correctly, exactly. That's what we're about to find out. So let's look at the Haskell implementation. Okay, I asked QuickCheck to run this property, and QuickCheck said, yeah, I ran this with 100 examples, and it always worked. So that doesn't mean it always works, but it worked for 100 examples. And next time you run the test, it will use 100 different examples. And then the next time it will use 100 more different examples. And so over time, you get a pretty good coverage because it gets into different areas of your input data and finds out a lot of interesting things there. And if it keeps telling you, yeah, it's correct, then okay, so far you have nothing to worry. But let's look at a counterexample. So I thought I'd challenge this a little bit, and I say, okay, if I reverse the list just once, it should be the same as before, right? Do you think this holds true?
If it's empty.
If it's empty, or if it's just one element, or if you have two equal elements, or if it's a palindrome. There are options where it's valid, but in general, it's not valid. Okay, not for all lists. And so I asked QuickCheck to run this, and here QuickCheck said, failed, falsifiable after 7 tests and 3 shrinks. And it also gives me a nice counterexample. It says the list with 0 and 1 in it is not just reversible once and equal. So this means QuickCheck started, so the 7th data structure it tried this on failed. Okay, I ran it again. And there it said, okay, after 4 tests, it got to the example 1 and 0. So a different list, a different example, okay? But as we can see, after some time, it will trip on some data where the property doesn't hold. And so it also gives me a nice counterexample. So the shrinking is a really interesting aspect because even if it has a large data structure, it tries to minimize it as much as possible while still breaking the property. So that you don't get a list of 100 items in there and then you have to figure out now why actually did this break, but it tries to give you a minimal example. And that's a very valid, very helpful thing because then your counterexamples are really minimal. And what you can then do is write a standard unit test with this example, fix it, and then you can be sure that this specific example will never occur again because you have the specific unit test for it. Okay? So now, why did I tell you this? Of course, because I want to use this idea for my functional essence and for the comparator. Okay? And how can we use this here? So, initially, what we would want to do is we want to do a reset of our data on both sides, right? This, what I show you now, all happens on both sides, like I initially gave you the idea, right? Against the functional essence and against the real server. So I reset on both sides, and then I issue random queries. And after that, I check. Okay? So now, what does this mean? Let's think about this for a bit. If I issue 100 random get queries, I don't really get anywhere because my internal state doesn't change, right? I want to change my internal state so that I can explore the state space and can see whether my functional essence actually behaves the same as the server in all sorts of combinations of states, right? So actually, it's a state machine, okay? Secret. So what we here want to do is we only want to focus on the modifying requests, right? So we do some modifications. We do a post request, a delete request, so that we modify the internal state of our server so that we actually have something to compare to. And for the checks, if you think about this, yeah, it's quite interesting to check the actual result of the request. But for the modifying requests, we had this previously, this is generally something like 200, okay. I mean, if this is not the same, then yeah, we can directly, like stop it because we know something went wrong. But if it's 200, okay, then we still need to check a bit more. And that's what we also do. So we check the result of the request as well as we use get requests to cover the internal state. Because as I said, I'm not really interested in the internal state as such, but I'm interested in what gets exposed through the API. And that's what the get requests give me, right? This could be easy, so I just get this and this and that. It could be a bit more complicated if I have parameterized requests, so I need to make sure that I explore this also a little bit in my testing. But in general, this is what I need to consider, look at the result and look at the state as I get it through my get requests, through the API. And then I can repeat this, so I do another modification, compare, do another modification, compare, so that I actually move in the state space. I don't only add one pet, I want to have multiple pets in there and see what happens then. And then also I can generate a summary for to look at, and also I can do repetitions and with resets in between, so that I start from 0 and go through one path, start again, go through another path, start again, go through a third path. Okay? In what I show you next, I've only implemented the smaller loop, not the bigger one, but I think that's not a big deal to add just one more loop. So how did I implement this? I like this graphics, and I think it's true. So if you get lots of what the fucks, then please speak up and we can sort this out. I think we have enough time to look at this. Okay? So this is how I implemented this, also in Node.js, like I said, First of all, we need to capture the requests we want to run against the server and the functional essence. So here we start out with the resets. And then we say, okay, let's pick 50 requests. And here I choose from the modifying requests and add these to this array. And then I map over those requests. And I invoke a function called request and compare that actually does the request and then does the comparisons I talked about. And then in the end, I collect the results that came out of this and then, send them back or do a console log or something. Okay, how do I generate all those requests? So I divided them in 3 groups. First I have the resets. So here it's just one. Then I have the modifying requests, which are my post and my delete requests, always with a random pet. We will look at this in a minute. And then we have the comparisons, which here's my get request for all pets. So this is fairly simple, but if you have more API endpoints, then of course you would add them to the list, and then you would, go through them in random order, because you would pick one from this list and do the modification and then pick another one from the list. So how do I generate the pets? So we have 5 different species, and I decided to go for 3 set names. So we have 15 different pets in total, and so we have a chance that over time we will also see the same pets. So we might also see an action where we first add a pet and later on remove it or something, so that we can explore these paths as well. Okay? So if you have more complicated data, I'm pretty sure you will, you might want to put some more effort into this generator, because initially I thought, I can just use a random pet name, but of course I will never ever get the same pet name twice. And so this aspect of adding a pet and removing it would never ever be covered. And so you need to think about this a little bit, how you structure your generator and how you actually create your data. Yeah, and then here I say, okay, I pick a name, a price, a species from some range, and then I create this random pet out of these data. Okay, so pretty straightforward. Now back to the main loop. Here I said, okay, we map over the requests after we have established them, and then we invoke the request and compare function. And this is what we will look at next. And in here I run the request, first against the backend and then also against the functional essence. And if the results that come out of it are not identical, then of course I need to, say, oh my goodness, something went really wrong here. Otherwise, if the result matches, then I will still need to compare everything here. And that's the next thing. This is the details of the run request. So here we run the backend and the essence in parallel, and we request we run the request here either for the backend or for the functional essence.
Microphone a little bit nearer.
Okay, better.
A little bit higher. Can I?
Mm-hmm.
Okay.
Okay?
Mm-hmm.
Yeah, good. Let's see how this works. Okay. So far, so well? Or is this really like crazy confusing? Okay. Yes? No? Any questions? Good. So, yeah, then we need to compare everything, like I said. And here again, I use all my comparisons that I had set up before. So these are all GET requests. And then for these GET requests, I basically do the same. I run this against the against the backend and the functional essence, compare the results. If they are identical, then great. And if not, so here I try to implement something that would give me a nice diff result, because if I get like these huge JSON objects thrown at me, it's not very easy to understand where the difference is. Also because I did not implement the shrinking. That would be another aspect that needed a bit more consideration. Yeah, I thought, yeah, maybe I can implement something like in GitHub, or in Git, you get this nice diff view. I got somewhere, but yeah, I'm not exactly convinced. But this is just a prototype, and so I think for that, yeah, fair enough. Okay, so, and then, I run this over all the comparisons, and in the end, I pick out the non-matching ones, and then I can complain here and say, there's a problem, Look at this sequence of requests I fired, and now I have a difference. Can you please write a test for this and then fix it? Okay? So this is the general idea. Right? Makes sense so far? Okay, good. So, I had these questions before, and I said, did I cover the completeness, and what about the validity and everything? And now I would like to go back to these questions and answer them for CDCT on the one hand and for the functional essence on the other hand. Okay? So, the questions of completeness were, did we capture all the requests and responses and all the different combinations? And for CDCT, yeah, we need to write the tests ourselves. So we are responsible for the completeness. And we must make sure that we covered all the aspects, all the interesting branches and everything, right? For the functional essence, we use the quick check approach. And that means we just don't write tests. So the functional essence will sort this out for us over time, because it will go through this path and that path and yet another path, and it will explore the system and build up differently shaped data and then run experiments on this. Okay? The only thing we do is we specify the possible routes. So we need to give all the endpoints to the functional essence so it knows which ones to follow. And then completeness is established over time. Okay? We also asked ourselves about the validity, or I asked myself at least, what about the data? Is it valid actually? And with CDCT, we need to establish the state in the backend ourselves. So we are responsible for the validity here and for the correctness of the state. And for the beyond CDCT, we establish the state through API calls. So it's valid by definition because it's something that can be achieved by coming from the outside. So that's exactly what our state space is about. All the differently shaped data that we can create through the API. And that's what we exactly do here because we only go through the API. And we can always reach the state because we just got there, yeah? So it's reachable by definition. And of course it's correct only if we don't do any coding errors. But we have the same issue further up with the CDCT because there we also need to make sure that we implemented the state in a correct way. And setting up a complicated state just out of the blue and making sure that that's correct, I think is a bit tougher a problem than just making sure that we establish this step after step. Okay? We also talked about the maintenance and what do we do with our hundreds of CDCT tests that we will inevitably get after a while. And yeah, for CDCT, I said this already, it's the same as maintaining normal tests. We need to have a strategy to make sure we cover everything and we don't have too many duplicates in there. We can, of course, use code coverage to figure out which areas might be untouched and where we might need to look into. But for beyond CDCT, we don't establish any tests. So the only thing we need to make sure is that the comparator knows all the routes. So if we don't add a route to the comparator, it can never go there. So we also create a sort of blank area there that we don't cover. But we can also identify this with code coverage. So if we never ever hit this endpoint, then we can think about, oh yeah, maybe we should check this, in the comparator. And also, I believe comparing a list of API endpoints, to the real implementation is so much simpler in factors simpler than making sure that we write enough tests to cover our code. And if we miss out a route in our functional essence, then it will explode on us because we will invoke it because it's in the comparator. The endpoint is in the comparator, but if we didn't implement it in the functional essence and we invoke it, then boom. Okay, so we see this, we fix it, all easy, all good, right? It immediately happens while testing. If we miss out on logic in the functional essence, that could also happen that we just forget to implement some part of our business logic in there. Then initially, if we do a prototyping with the functional essence, we will discover this because there's some behavior that's not there. The product owner says, yeah, if you click there, it should do this and that. And if it doesn't do that, then you can look into the functional essence, which is a very simple implementation of your domain logic, and just look at it and figure it out and fix it so that, the prototype works as expected. Later on, you might run into issues. For example, you decide to actually change the business logic and then you change it in the production code, but you forgot to add it to the functional essence. Might happen. But then you get comparison errors because they both behave differently. And then you also know you need to look into this. And if you just added this new feature to the backend, then you will probably know that this is a problem with the functional essence and not with the actual production code. And so it's also easy to catch and easy to repair. And so we have good mechanisms in place here to help us point out where we omitted things and didn't implement them. Yeah, so that's basically it. I'll leave you with some words of warning. So this is not an easy solution, and the world remains complicated, so we still have all sorts of complications here. if your services are cut in the wrong way, then your services are cut in the wrong way, and you can have as much functional essence as you want, they are still cut in the wrong way. So this does not help you with that, okay? This is also not a golden hammer, and please don't try to apply this just everywhere because you think it's, wow, the nice go-to tool also. Please think about it, okay? Because here you are quite high in the test pyramid. So this is full integration, And please, we need these tests, but please make sure that you also have like the unit tests and everything to properly cover the behavior on a unit level. Okay? That's it. Thank you very much. And I think we have time for a few questions, if there are any.
Did you ever run into the situation that you had the created response giving back the created object with some kind of timestamp when it was created?
Yeah, of course. If you have timestamps in there, then you need to address this in your comparator so that it doesn't look at the timestamp, because this is, of course, wrong.
So did you run into that problem already, or is it still something to be?
I personally didn't run into this, but these are the things, IDs, timestamps, stuff like that, that's uniquely created, then you need to skip over this. This is, by the way, the same with CDCT. You also need to make sure that you don't compare on the timestamps and everything, but usually you can specify this in your contracts.
Is that something where your whitelist?
I think you can parameterize this. This depends on the tool. So you can sometimes say, yeah, this is like sort of maybe it's like it must match this. Oh my goodness! Wow. The regular expression. Thank you. Sorry. So you can specify a regular expression, or you can say, no, it needs to be in that range or whatever, and then the comparison says, okay, I understand, I don't look too closely at this. Yeah, more questions.
If my real service, hi. If my real service wraps or decorates an external service, will my fake service talk to the external service, or how do I extract this external dependency?
Yeah, so if you have another external dependency, yeah, I have no out-of-the-box answer, but my gut feeling would be you should better cut this off so you don't get too many weird effects in your functional essence. So you should have a specification for that as well, and then you need to see what you want to invoke in the second service, and then just cut this off in your functional essence, most probably. And then have the same for the next layer, So you get this layer by layer by layer. But it depends. Sometimes it might be easier, if it's a trivial service, I don't know, date service or something, date time service, then you would probably just, maybe call it, or maybe just, ignore it, something. So this is not like something established. This is not a tool or anything. This is just some ideas I decided to throw at you. Thank you for bearing with me. I sometimes think it would be interesting to turn this into a tool, but I don't really have a good grip on how exactly to solve all these tiny issues. Like you said, what if there is a next service and people ask me, what if I don't have HTTP? Yeah, you need to implement this as well, right? But if it's a tool, then people would expect this, and then you get really, interesting requirements.
But what about bugs in your functional essence? If there's anything that I've learned is that I tend to introduce bugs.
Yes.
And even if I'm trying to do the most simplest way of my domain,
yes,
there has to be a risk that you trust something that is wrong. Right?
Yes. So the risk is there, right? That's why I think it's also very interesting to do the prototyping with it, because then the business people will look at it and they might discover your bugs, or there is a chance that you did not introduce the same bug in your backend as well. Sometimes you do, especially if the same person writes both. Then you might have the same bug in both, and then you wouldn't discover them via the comparator. But because it's also a nice way of prototyping, you might get another, attack vector on this, because you can really look at it with humans who understand what should be going on, and then hopefully find this out. But yeah, this is an issue. Same with your tests, right? If you write buggy tests, tests that have wrong expectations, then same issue. But tests are harder to prototype.
Just one more question. Hi.
Yes.
My question is that how we can handle the situation if we have two different teams, an API producer and an API consumer. Mm-hmm. In this case, as a producer, I have to provide the essence, and the consumer team can integrate this essence into their CI process, for example,
yes.
and they can investigate if something is break in the contract.
Yes.
So this is the use case.
Yes. Mm-hmm. So the consumer team would use the functional essence, like you probably also do with the CDCT. I don't know if you use this, but I once was in a team and they were using CDCT, so they would write the contracts and would publish them via Maven, whatever, and then the front-end team could get them and could create the mocks and work against the mocks and synchronize in this way. And I think with the functional essence, it makes sense to work in the same fashion, so that the provider who actually knows what's going to be provided also writes the functional essence. So somebody also suggested maybe there should be yet another team to implement the functional essence. I don't know, might be an interesting aspect to do it that way. So that would also eliminate sort of these brain bugs, if you decide to implement both in the wrong way. So if you have somebody else look at it, like in the space rockets or something, where you have the same system implemented multiple times by different teams, and then they can, compete which one is the correctest or so. Yeah, cool. Thanks very much, and enjoy the rest of the day.